Have you ever wondered what would happen if gravity suddenly disappeared? A fascinating thought, isn't it? Gravity, that invisible force keeping us anchored to the ground, our coffee in our cups, and the moon in orbit around the Earth. It's so ubiquitous, so fundamental that we often take it for granted. But let's imagine, just for a moment, that gravity decided to clock out. The immediate effects would be, to put it mildly, catastrophic. We'd all be flung off the Earth's surface into space, along with everything else not firmly attached. Our atmosphere would disperse, and the Earth itself would start to break apart. Even the stars in the sky would look different, as their light would no longer be bent by Earth's gravitational pull. So, while it might be fun to dream about floating around like astronauts, the reality would be far less pleasant. Gravity, as it turns out, is a lot more crucial to our existence than we might realize. Gravity is a force of attraction that exists between any two masses, any two bodies, any two particles. It's a concept we're all familiar with on a daily basis, even if we don't always realize it. When you drop an apple, it falls to the ground. When you jump, you come back down. It's gravity at work. Let's delve a bit deeper. Gravity is one of the four fundamental forces of nature, alongside electromagnetism and the strong and weak nuclear forces. It's a force that every object in the universe that has mass exerts on every other object. It's the reason why when you let go of that apple, it doesn't float away, but rather it falls to the ground. But gravity isn't just about falling apples. It's a cosmic force. It's the reason why planets orbit around the sun instead of drifting off into space. The sun's massive size creates a strong gravitational pull, keeping the planets in their orbits. Imagine gravity as a well. The more massive an object, the deeper and wider its well. The sun's well is so vast that it keeps the Earth and other planets circling around it. The law of universal gravitation, first formulated by Sir Isaac Newton, gives us a mathematical way to understand gravity. This law states that every particle in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. It's a mouthful, I know, but it simply means that the larger the masses or the closer the objects, the stronger the gravitational pull. So, there you have it, the basics of gravity. It's more than the force that keeps your feet on the ground. It's the cosmic glue that holds the universe together, keeping planets in their orbits and stars in their galaxies. And though it might seem ordinary to us, it's a force that's as fascinating as it is fundamental. Gravity is the invisible glue that holds the universe together. Gravity is consistent, universal, but full of surprises. This intangible force, so integral to our lives, holds some intriguing secrets that can boggle the mind. Let's start with a simple yet fascinating fact. Did you know that the strength of gravity isn't the same everywhere on Earth? Yes, you heard it right. If you were to travel from the poles to the equator, you would actually weigh slightly less at the equator. This is because Earth isn't a perfect sphere. It's an oblate spheroid, meaning it's slightly squashed at the poles and slightly wider at the equator. And due to this bulge, there's a bit more distance between you and the Earth's mass when you're at the equator, leading to a slightly weaker pull of gravity. Now, let's shift our gaze from the Earth to the vastness of space. Astronauts living aboard the International Space Station, or ISS, experience what we often refer to as zero gravity. But here's the twist. It's not that there's no gravity in space. In fact, the gravity at the ISS is about 90% as strong as it is on the Earth's surface. So why do astronauts float? Well, they're essentially in free fall, constantly falling toward Earth, but also moving forward fast enough to keep missing it. This creates the sensation of weightlessness. And it's not just the astronauts. Everything on the ISS, from the equipment to the droplets of water, is falling at the same rate, creating an environment where everything floats. This phenomenon, known as the equivalence principle, is a cornerstone of Einstein's theory of general relativity. Gravity may be invisible, but its effects are undeniable. It shapes our world, our experiences, and even our bodies in ways we often take for granted. As we continue to explore the universe, who knows what other incredible facts about gravity are waiting to be uncovered? The mysteries of gravity continue to unfold. Gravity is not just a force that keeps our feet on the ground, it's also a cosmic artist, able to bend light itself. This phenomenon, known as gravitational lensing, occurs when a massive object, like a galaxy or a black hole, creates such a strong gravitational field that it distorts and magnifies the light from objects behind it. Imagine a giant cosmic magnifying glass, bending and stretching the fabric of space and time. But it's not only space that gravity affects, it also impacts time. This is a concept known as gravitational time dilation, a prediction of Einstein's theory of relativity. According to this theory, the stronger the gravitational field, the slower time passes. This means that if you were to stand on a planet with a significantly stronger gravitational pull than Earth, your wristwatch would tick slower compared to a clock back here on Earth. It's a mind-bending concept, but it's been proven by precise experiments with atomic clocks on airplanes. Now let's journey to the most extreme example of gravity's power: black holes. These are regions of space where gravity is so strong that nothing, not even light, can escape their pull. They're like cosmic vacuum cleaners, swallowing everything that comes too close. Black holes are formed when massive stars collapse under their own gravity, creating a point in space with infinite density, known as a singularity. Here, the laws of physics as we know them cease to exist, making black holes one of the most fascinating and mysterious objects in the universe. Black holes are not just interesting for their extreme gravity, they also give us clues about the nature of gravity itself. They're the ultimate testing ground for our understanding of how gravity works, pushing our theories to their limits. As we delve deeper into the universe, gravity continues to astound and amaze us. It's a force that shapes galaxies, bends light, warps time, and creates cosmic wonders like black holes. As we continue our exploration, who knows what other astonishing secrets gravity has in store for us? Without gravity, life as we know it would be impossible. This is not just a bold statement, it's a stark reality. Let's take a moment to appreciate the unsung hero of our universe: gravity. Gravity is the invisible force that shapes our everyday lives in ways we often take for granted. It's the reason we stay anchored to the ground, why the oceans ebb and flow, and why our planet orbits the sun in a perfect dance of cosmic synchronicity. Consider the human body. Did you know that our bodies are designed and adapted to thrive under the influence of gravity? Our muscles and bones gain strength through resistance against this unseen force. Without gravity, astronauts in space often face muscle atrophy and bone loss. It's a testament to how vital gravity is to our survival and well-being. And it's not just about us humans. Gravity plays a pivotal role in the natural world around us. It's the force that shapes the Earth's spherical form, guiding the flow of rivers from high mountains to low valleys, and even influencing the growth of trees reaching skyward. But gravity's influence extends far beyond our own planet. It's the glue that holds galaxies together, the force that causes stars to collapse into black holes, and the architect of the cosmic ballet, where planets, stars, and galaxies move in harmony. And let's not forget about time. Yes, time itself is affected by gravity. According to Einstein's theory of relativity, the stronger the gravitational pull, the slower time passes. So in a sense, gravity is the master of both space and time. So, the next time you're out for a walk, or simply sitting down enjoying a cup of tea, take a moment to appreciate the invisible force that makes it all possible. Remember, every step you take, every sip you make, gravity is there, working tirelessly in the background, ensuring the universe operates as it should. Gravity, the unsung hero of the cosmos, keeps us grounded in every sense of the word. Gravity is a constant, invisible force that shapes our universe. It's the invisible puppet master, pulling the strings behind the scenes of our everyday lives. We've embarked on a journey together, exploring the fascinating facts about gravity. From the thought experiment that sparked our curiosity, to understanding what gravity actually is, and examining its unsung hero role in our universe. We've discovered that gravity, while seemingly simple, is a complex and powerful force. It's the glue that holds everything in the universe together, from the tiniest particles to the largest galaxies. It's the reason why we stay grounded on Earth and why the planets orbit the sun. It's the force that bends light, warps time, and even shapes the universe itself. This constant, invisible force affects us in ways we often take for granted. So next time you pick something up and let it drop, remember the extraordinary force at work. Gravity, the unseen power that shapes our universe.